Hi everyone, in this video we will explore how to use the match service to snap GPS points to the road network in the most plausible way. You can find the notebook used in this video linked in the description on my GitHub repository. If you want to read more about the match service, please click on this link to visit the official documentation. Next, we are going to work with a GPX file. Where do you get that from? Let me show you. Click on this hyperlink that will open OpenStreetMap. Click on GPS tracks, and here are some public GPS traces that you can use. In my case, I used the Morocco map, so I searched for a public GPS trace in Morocco and downloaded it. In your case, search for a trace in the area you selected in the beginning of this course. So if you are from France and selected the France region, make sure to search for a public GPS trace in France. If it is difficult for you to find it, what you can do is click here, search for OpenStreetMap public GPS trace and add the region. Let's say United Kingdom. And that will give you some GPS traces in that region. So you can see that here we have UK, and now it filters traces tagged with the UK tag. After that, click on one of the public traces. Here is a preview and hit download. You can see that the file is a GPX file, and this is what we need. Now we are back in our notebook. Here I am defining a point class with 3 fields this time. We have the latitude, longitude, but this time I added timestamp field because we need this when using the match service. And this timestamp needs to be in this Unix timestamp format. So make sure to not use any other format. After that, we use the parse GPX and extract points method to parse the GPX file and extract the data points. Let me open the GPX file just to show you how it looks like. Here it is. You can see that here we have the points. Let's see. Yes. So all these tracking points, you have the latitude, longitude, and the timestamp. And this method will try to go over all those entries or all those items in the XML file and extract them. So as you can see, we are searching for the tracking points. We also extract the default time and convert it to Unix timestamp. And after running this, we get 1420 points. Let me rerun it just to make sure that it is working. Great. Let's display the first 100 points in the map as circle markers. I am limiting the number of points to use because by default, OSRM limits the number of points to be used in a request to 100. Don't worry, I will show you how to change that limit in an upcoming video. After running this cell, as you can see, here are the points. Here we should have 100 of them. Great. After displaying the points, we can see that some of them are outside the road, like these. That's because GPS traces are not 100% accurate because sometimes the signal is not as strong as it should be, and that creates these anomalies that you see in the data. This is why we use the match service to correct these inconsistencies. Now let's see how to use that service. Let's skip the general options because we have talked about these in the previous notebooks. This service uses additional options like the timestamps and radiuses. This is why I added timestamp to the point class. Timestamps are used to help OSRM infer the order of the data points. So if you have a list of points that are already sorted by time, there is no need to provide the timestamps option. But if those points are not sorted, then OSRM will use the timestamps option to sort those points. Radiuses, on the other hand, accounts for the inconsistencies of the data points recorded by the GPS system. And I have 2 examples for you that will show you the role of this option. Let's construct our endpoint and make the first request. In the first case, we won't use the radiuses option. This is why I wrote no radiuses. Here we are defining the global variables. Then we are creating the coordinates and timestamps parameters. After that, we will pass the URL and parameters to the get method. In the previous notebooks, I didn't use this parameters option that the get method provides, but since we are having a lot of parameters, the URL endpoint will be big. This is why I broke it into this format so that it becomes easier to read. Let's run this. Okay, so it tells me that I don't have the host because I need to run this and then run this one. I get 200 as the status code. This is great, which means that the request was successful. But let's go back and change the max point to use to 200. Now I'm still getting 200. In your case, you might get an error because I changed the limit and my limit is 500. So if I go to 501, I should get the error. You can see that here I get 400. And how do I know that this is an error? Basically, I will use the response variable and extract the data. And here it says too many trace coordinates, too big, which means that the number of points that I sent through this request was bigger than the limit that OSRM expects. So now let me go back to using that variable. But as I told you in an upcoming video, I'll show you how to change this limit as you like. Let's run the cell again, and here we get 200. Let's continue. Here, after extracting the data, we can see that we have the matchings. This is what we need. From matchings, we can extract the matched routes. We should be able to extract just one route. And here are the items inside this object. This might seem familiar to you. We have seen something like this in the route service notebook. Here you have the geometry of the whole path. The path can be divided into multiple legs. Weight basically can be the duration or the distance. You can change that. You have the duration of the travel and the distance of that route. Here I am using the volume map to create a volume map with those points, with those 100 points plotted initially. Here I have two colors so that I can alternate between the legs. Each leg will have a different color. Here we have the legs. We iterate over all the steps. And then basically I draw the legs, and for each leg I have a pop-up. Let's see how this looks like. As you can see here, initially the points, some of them were snapped to the street network. Some of them were outside the network. But this match service was able to give us a route that is snapped to the street network and follows the points nicely. This looks interesting. Here on the far left, we can see that we did not make a U-turn to change the direction. Instead, OSRM found a way to change the direction with no sharp turns. Overall, it did a great job following the original GPS data. And this can change based on if we change the radius's values. Let me scroll down. There is also a confidence value. If it is close to 1, it means that OSRM is confident that the matching route is as accurate as possible. Here we have 0.01, which is very low. And I think the reason for that low value is this. Here, if you look, we don't have any data points here that were present in the original GPS trace data. That's why we get a low confidence value. But even if you get a low confidence value, you should try to plot the route to see if that follows the data points, because sometimes what we get here might be the best solution because the GPS data was not that great. Now let's see the second example. This time we will include the radiuses option when making the request. Everything will stay the same, except now we have this radiuses parameter that we will give to the get method. By default, the value for radius is 5, but here we are overriding that with 20. Let's make the request. Let's extract the route, and as you can see, the confidence value increased. Let's plot the route to see how it looks like. Notice that by changing the radiuses, the route was affected. So Play with that option until you find the result you like the most. I'll change it one more time and I will put 15 instead of 20. And I think this should increase the confidence level drastically. Yes, we get 68%. Let's plot the map, or let's plot the route, and you can see that we get something totally different. As I told you, play with that value until you get something that looks fine to you. We arrived at the end of this video. I hope that you found it informative and learned something from it. In the next video, we will explore the trip service.